Welcome to the course Digital Transformation and Technological Innovation. So, we are into our third module, that is transitions in software markets. So, let us continue from where we left in the last session. So, next question that we are going to focus on is is this, that what are the risks and concerns linked to PaaS and IaaS, platform as a service and infra as a service. So, some of the benefits and risks are common with SaaS, that is software as a service. So, some of these benefits and risks that we have discussed when we covered SaaS. So, those are shared with PaaS and IaaS also. Now, we will talk about the additional challenges that might be faced in case of PaaS or IaaS options, right. So, first step is that if you are using complex set of systems and we are going to PaaS or IaaS with our complex set of system, then it might be tough to set up, because you would be doing the setup on someone else's hardware, which is actually a cloud provider, a cloud vendor. So, this whole setup process, while it might be comfortable for our own system on prem setup, right, but because of the complexity that could be there in the system, doing the same thing on a cloud environment, which is very generic. Cloud vendors try to serve to as many firms as possible, right. So, they are trying to cater to a market. So, because of that, some generic services are there. The environment is such that it could support the generic services which covers most of the firms, right. But when you are having complex setup systems, then one has to think whether the risk will go up in case of going for the cloud option, right. So, that is the recommendation. So, it would be better to focus on new system instead of legacy ones. So, if you are having some new systems, then in that case you might go for the cloud, but if you are having legacy system which might be even more complex, right. So, in those cases you might be better off with your on-prem infrastructure with on-prem computing, right. So, new system you might still go, even if the system is complex, you might still go for cloud or you might still consider cloud, but if it is a legacy one, it is better to stick to on-prem. Now, few more additional challenges that are faced in PaaS and IaaS. So, another one is regulatory or compliance issues. So, some of the new or legacy system, both kinds, they might be fulfilling some sort of regulatory or compliance requirement. So, if that is the case, one has to see whether if they go for a PaaS solution or IaaS option, whether that would be difficult to fulfill, right. So, regulatory and compliance issues, one has to see how you would be able to fulfill those same thing in a cloud setup, right. Then the next is financial trade off. So, this is the one of the important aspect here, that what would be the cost of owning an operating system over time, and you do a financial analysis or financial trade off kind of analysis with variable cost on cloud over the same period, right. So, cost of owning and operating systems over time, given a period of time, versus variable cost that you would incur if you go for the cloud, right, and for the same period. So, you can do that financial analysis and then figure it out whether it is a good option for your enterprise, right. So, some recommendations are mentioned here, for example, rent for low volume, unpredictable or variable workloads. So, if you are having low volume, right, so that means if you go for the cloud option, because of the low volume, you might be able to reduce some of the cost in case of cloud, because if you go for higher storage on cloud, it might be costly. So, low volume and unpredictable, the kind of workload that might be there might be unpredictable. Low volume in the sense number of transactions and everything would be on the lower side. So, along with the storage, data transfer, other costs will also be lower. Unpredictability is there, that is better served on cloud. So, therefore, this also supports the cloud option, and the variable workloads, right. So, when we are into low volume, unpredictable or variable workloads kind of scenario, then we might prefer to go for rent option, that is cloud option, right. And if we are having high volume, that means lots of transactions, that means lots of data transfer might take place, storage requirement might be there, right. So, if that is the case and we also having high stability workloads, that means we know the kind of workload that is going to be there, it is kind of stabilized, and therefore, you can go for the buy option, because there is a certainty that you get, and the cost option might also favor you, because higher volume is there. So, higher volume, higher stability workload, you can go for on-prem, that is buy option, and if you have low volume, unpredictable variable workload, then you might go for the rent, that is cloud option, right. Then these are the common concern that we just talked about. So, complex setup system we talked about, then regulatory compliances issues, and then the financial trade off that we just talked about. So, these could be the additional concerns in addition to what we have already covered in case of SaaS. So, some of those things apply to PaaS and IaaS also, right. Now, moving on to another alternative, that is hybrid cloud, right. So, there is another modern alternative, that is hybrid cloud. So, let us talk about that also, right. So, hybrid cloud is essentially about that you are having your on-prem computing option, plus you are open to cloud option also. So, you are hovering around both on-prem and cloud option, that means you are into a hybrid setup, you do both, right, the cloud and the on-prem. That on-prem could also be a private cloud. So, it could be cloud on both sides in case of a hybrid option, but private cloud would be in a way we can say on-prem / private cloud, and the second thing would be the public cloud. So, in that case we can go for buy option for base workload. So, base workload could be stable high volume, right. So, whenever we are into high volume stable thing, that is same from here, right, that remains same. So, whenever we have a workload which is stable high volume, for that we can go for the buy option, that means on-prem private cloud option, right. And whenever we have sort of burst capacity requirement, right, that means the spikes might be there in that workload, there might be variability in the workload, or the workload might be unpredictable in nature, then rent option or the cloud option might be more suitable. So, rent for the burst capacity, that means scalability might be better via cloud. So, the workloads which might require scalability, then you might go for rent option, cloud option to get that burst capacity during peak demands. And if your workload is kind of stable or high volume, you can go for base workload, and therefore you can manage that on-prem or private cloud, right. Now, another scenario that could be there is during periods of spiking demand or black swan events. So, spiking demand, we understand that peak periods. So, we can go for the rent option, that is because cloud provides better scalability, right. But what are the black swan events, right. So, we have defined black swans here. So, black swans are unpredictable events having a spiking impact, right. So, there might be a there might be event where the volume goes up for certain region, which was unpredictable in a sense that you are not expecting. So, you typically expect peak periods during certain hours or certain days, or certain seasons in a year, festive season, other seasons. So, if the spike, if it is not predictable and it has somehow came about, it is like a black swan event, unpredictable, right. It might also be a cyber attack scenario. Cyber attacks are unpredictable. So, there might be your competitors which might be trying to bring down your server or bring down your service, or it might be a cyber attack from foreign countries, right, to bring down certain important services, whether private or public, right. So, there could be unpredictable events, and which might have a spiking impact. So, cloud might be better option to deal with those unpredictable events also, because of the scalability that might be there, right. So, cyber attacks might exhaust themselves when they face the scalability of cloud, right. But in case of on-prem, they might be able to disturb the service, right. So, whether it is about a spiking demand or the black swan event, it is better, that better to go for cloud in those scenarios, right. Then we talked about the burst capacity. So, what is cloud busting? So, cloud busting is actually a scalability solution. So, many cloud vendors, they will be giving this kind of option that scalability solution or the cloud services that they are providing has the cloud busting support. So, this is a scalability solution for seamless shift of workload to the cloud to provide access capacity. So, in case you are into a hybrid setup and you are running something on prem or private cloud and you want some scalability support for cloud busting scenario. So, only that part is also offered by cloud vendor. So, that is why we are referring this as a cloud scalability solution for seamless shift from of workload from maybe on prem / private cloud to public cloud to provide access capacity, right. So, this was about the modern alternative that is being increasingly being adopted by medium to large size firms. Now, other additional challenges that could be there in case of PaaS and IaaS solutions. So, one is mission critical systems. So, earlier we talked about the complex systems and how it could be difficult to deploy that in cloud setup, which is sort of generic in nature. Similarly, for mission critical system also you are essentially exposing yourself to the risk of potential risk of cloud collapse. So, what happens if the cloud services are shut down for some reason? There have been such incidences which have been reported. So, there are certain reported issues where Amazon and Adobe, their cloud apps or their cloud services or cloud computing services in case of Amazon, they faced issues in terms of collapse, right. So, services were down for number of hours, but if you are running mission critical systems, can you then rely on cloud, right. So, though cloud vendors, they will typically claim that they offer less downtime and failure than conventional data centers. Now, here becomes the tricky situation that even for your for your mission critical systems, even if you are going for on prem option, right, you will more likely have conventional data centers. Then whether that would be better off over cloud or not, because the top cloud vendors, their claim is that they are better because they have been doing this thing for a number of years with large infrastructure, cloud infrastructure, that is. So, they claim that less downtime and failure in comparison to conventional data centers. One has to think about what to do in case of mission critical system. Even if you run your own conventional data center, there might be scenario where there could be issue with your own data center also, right. So, another claim that is typically there is fault tolerant provisioning with multiple data center. So, many top cloud vendors, that is Google, Amazon and Microsoft, they do have multiple data centers spread across the globe, covering the whole geography, right. So, therefore, we can say that in a way they would be able to provide fault tolerant provisioning. So, one has to see that for their mission critical systems, whether they can go for the cloud options that are being offered by these top cloud vendors. But then there is another issue that is related to mission critical system, that whether there is some data that you don't want these vendors to be privy of, right. There could be secrets related to mission critical systems, or there could be some unique things related to mission critical systems that you don't want to expose because of the public cloud services that you take. So, those concerns can also be there. So, these additional challenges firms have to look at when they decide on whether to go for PaaS and IaaS option. Moving on. Now, our next question is, what is the impact of cloud computing on the IT industries, right. Now, so much of workload, so much of computing is moving towards cloud and has already moved towards cloud. Now, it will obviously have a direct impact on conventional data centers. Lots of firms who used to have their data center on prem, and many of them still continue to have. How all that is impacted currently in an ongoing fashion, and how in future, right. So, portions of traditional hardware sales have actually shifted to the cloud hardware sales. So, many of the hardware manufacturer or computer manufacturer, the hardware components that they were selling for conventional data centers, selling in a more traditional way. So, that is traditional hardware sale, that has gone down because small to medium sized firms, they have moved away from managing their own data centers or server rooms to towards cloud. So, therefore, it is the cloud infrastructure that needs to go up. So, therefore, the hardware sale will also move towards cloud, right. Now, the cloud vendors are these themselves, these firms are big firms. So, therefore, they will have higher negotiation power when they deal with the hardware manufacturer or computer manufacturers. So, therefore, margin structures of computer manufacturer, hardware manufacturers would be impacted, because they would feel that they were better off dealing in a traditional hardware sales scenario than in a cloud hardware sales scenario, because most of the demand going forward as it is being catered by the cloud vendors, they will gather more power, they will accumulate more power, and they will be in a better position to negotiate for prices with these hardware and computer manufacturers. So, therefore, computer and hardware manufacturer, their margin will take a hit, right. So, increase in capital spending on server farm, that is happening. So, server farm is something that these cloud firms are deploying, and to expand their cloud infrastructure, right. So, much of the sales is happening towards cloud and towards server farms. Now, if we look at the traditional margin structure, portion of software sales, right, that is also shifting to SaaS uses. So, this shift is also happening. So, some of the traditional software sale that used to happen, now companies will go for the SaaS services. Small to mid organization, they will go for the SaaS services, and therefore, the traditional software sale will give way to cloud sale. So, that shift we are talking about here. So, traditional margin structure will again be impacted because of this, right. So, earlier for additional copies, the software vendors, software firm, they used to make lots of money. That economics we have already talked about in previous sessions, right. But because of the cloud, there is a shift, there is an impact on margin structure, because when you sell to a cloud vendor which is having higher negotiation power, even in the case of software also, that will impact your pricing plans and the margins, right. Now, similarly, if we look at what happens to the IT job market and skill demand, right. So, because there were lots of conventional data centers that were running, there were lots of job positions that were there in terms of to support those conventional data center, whether it is about cooling, networking setup, IT admin role, and many server related roles. Lot more jobs were there in a conventional data center setup. But as number of conventional data center go down and much of the computing moves to cloud, then there would be a shift in the IT job market, and the shift in the kind of a skill that is being demanded by the IT job market, because the jobs will move from conventional data center roles to cloud computing roles. So, more jobs, this has already been happening, and in future it will happen even more, right. So, jobs have already started shifting, already lots of jobs shifted to cloud computing roles. So, essentially new entrants in the IT job market, they should be more familiar with cloud computing technologies to be able to get some of these jobs, which were earlier being catered by the conventional data centers, right. So, there is impact on IT job market and skill demand, and that is why you will see that there are lots of certification program and specializations that are catering to cloud computing. Then lower barriers for startups. While this shift is happening, the startups benefit, because if you are starting a new business and you have to manage your own data centers, conventional data centers, then the cost would be way higher, something that we have discussed in the previous session, right. If the monthly page views, 5 million page views, and what would be the cost to run that website, right. So, if you are a startup, it would be difficult for you to come up with a conventional server room or data centers kind of setup, or let us say medium to top tier setup, to be able to support your the kind of views that are coming to your website or server, right. But in case of, but because of the cloud, the prices go down, that we compare, right. The cloud options were economical, so startups get a boost, and barriers go down. So there would be lower barriers for startups. So they just need to focus on their app or software product, if we are talking about the software based businesses or app based businesses, right, or software business of selling software itself or apps itself. Then for those firms, they can take advantage of the cloud computing services, and they can reach to the market better, and they can capture the market better. So lower barriers for startups. Moving on, now we talk about the cloud infrastructure, right. Now as we have been talking that traditional data centers, they are being replaced in part by cloud infrastructure, right. Now cloud infrastructure, they are geographically dispersed across multiple countries, multiple cities, right. So traditional data center in a way is giving way to cloud infrastructure, which is spread across the globe, right. Now cloud data centers, what is their setup? So they consist of server farms, right, built using pre-configured rapid deployment server farm modules, because the demand of cloud computing is continuously going up. So therefore cloud farms, they have come up with these rapid deployment server farm modules, so they can quickly cater to the growing demand for cloud services. So they have come up with the rapid deployment server farm modules, and they can expand their server farms quickly using these modules, right. So these modules are also pre-configured. That means once you get some of these farm modules, essentially you got a server farm, a small server farm running the moment you connect it to the power, cooling and other setup, right. So this is very fast way of adding computing to cloud data centers. Now what are server farms? So server farm is a massive network of servers running software to coordinate their collective use. Essentially we are talking about in the cluster kind of setup that we have already spoken in our earlier modules, right. So there is a massive network of servers running software to coordinate their collective use. So these rapid deployment server formulas will be adding more servers to the same setup, and therefore server farm will have more capacity. Now to be able to have these cloud data center installations, what are the factors that the cloud firms look for? So there are certain regional factors that these firms look for to set up their cloud data center. One is cheap land, because there would be lot more land that would be needed to for these data center installation. So cheap land they look for. Then low cost power, because to be able to run these server farms and huge number of servers that are part of these server farms, to be able to power them and then cool them, there would be lot more power that would be needed. So therefore low cost power they look for in a region when they decide to open a data center there. Then ultra fast fiber optic connection. So all the load from all over the place will actually land up on these cloud data centers. So therefore they should be having very fast, or rather ultra fast networking connections. So ultra fast fiber optic connections, if that is already there in a region, so these cloud firms will prefer to open their data centers in such regions. Then mild climates, so if there are mild climate in a particular region, then the cooling cost could be optimized, and the cooling cost could go down, because much of the heat that is being generated, it can just be absorbed by the mild climate that is there in the region. So when these cloud firms they look to open cloud data centers, they look for cheap land, low cost power, ultra fast fiber optic connections, mild climates to cut cooling costs. Moving on, now for the cloud infrastructure, what are the non-regional factors that go in for data center installations? So national laws could be there which might put certain restriction or certain requirement. Industry specific regulatory environments could also be there. So, cloud firms might have to cater to that sometimes, right. So, may require cloud firms to keep data within a specific country or region. So, because of that, also cloud firms might open few data centers for their cloud infrastructure in different countries, even though they do not need to, because they already have lots of capacity in their original country where they are where they have set up the cloud infrastructure. But because of the national laws for different countries and industry specific regulatory environment, cloud firms may be required to keep data within a specific country, and therefore they might have to open few data centers in those countries to capture those markets. Now, if we look at what are the cloud data center hubs, where all these cloud data centers are residing mostly. So, Aspen in USA, that is considered to be the world's data center capital. So, most of these top firms like Amazon or Microsoft or Google, they have actually their largest cluster of their cloud data centers, they are hosting it there, right, Aspen USA. So, that has sort of become data center capital, right. So, you can now understand when we access cloud services for personal use, the free version, free tier, or maybe for enterprise or professional tiers, essentially which kind of where the server is that we are interacting with. So, the server more likely might be in Aspen USA. Then there are continent specific or region specific dominant hubs also. For example, for continental Europe, Frankfurt Germany is the city which is having the largest hub, right. So, that is continental Europe's largest hub is in Frankfurt Germany, right. So, this is one of the world's largest internet exchanges also. So, before cloud setup, internet exchanges were already there, which were being done through co-location services, and from one ISP to another ISP the internet would be exchanged, and so those kind of setups were already there. So, some of those cities which were having the internet exchanges, they over a period of time they also became a cloud data center hub. So, Frankfurt Germany is one of those examples. Now, London UK, that is London UK, that is UK's dominant hub, that is also a major transatlantic gateway from US to Europe. So, UK in a way becomes a gateway. The cabling, sea cablings goes to the likely to more likely to go through London UK, and then so therefore, it also becomes a dominant hub because of that traditional gateway position. So, internet exchanges, gateways, transatlantic or all those gateways or other oceans that are there. So, certain cities have been playing the role of internet exchanges or gateways. So, they have also become major centers to open these cloud data centers, because one of the reasons that we have already talked about ultra fast fiber optic connection. So, this is more likely to be there in these cities where internet exchanges or gateways are already there, right. Moving on, similarly Dublin, Ireland, this is considered to be Europe's cloud capital, because many of US tech firms, they have a good presence there, and because of that presence it has also attracted lots of cloud data centers, becoming Europe's cloud capital in a way. Then we have Singapore. So, Singapore in a way is a primary digital gateway. So, everything that is digital and if it has to connect to Southeast Asia, then Singapore becomes the primary digital gateway for that. So, it attracts all major global cloud firms despite land constraints. So, Singapore is a city nation, city country or city state, and therefore there are land constraints. Despite that, it has continued to be digital gateway, became digital gateway and continues to be that, and then able to attract the cloud firms. Then Tokyo, Japan, that is East Asia's leading powerhouse. So, that is also there. Then in case of India, we have Mumbai. So, that is leading market, and another reason is that major subsea cable landing point. So, again Because of that traditional infrastructure, the subsea cabling is there in Mumbai. So, because of that, this is also has become another city where lots of cloud data centers are there. Now, we move on to our next question, that is how does virtualization enable cloud computing. So, what was why cloud computing is so successful, why it was promoted so heavily in late 2000s, and Amazon was the first mover, and then the Google and Microsoft joined in and other firms joined in. So, virtualization is the underlying technology that has supported cloud computing, and has been the main reason why it is so successful. So, let us understand what is virtualization here. So, virtualization is a technology that allows a single physical server. So, we already knew that and we have already talked about that these top firms over the years for their different businesses, they have accumulated large data centers, lots of servers, and much of that computing capacity was unutilized, right. And then as the internet networking and internet penetration improved, they wanted to exploit that computing, they wanted to sell off that unutilized computing. So, essentially virtualization was the technology that could facilitate all that. So, this is a technology that allows a single physical server to be divided into multiple isolated virtual environments. That means if there is some same server you want to cater to, you want to serve to lots of businesses with the same server, because it has lots of computing capacity, it can effectively cater to all those computing needs, right. So, then you need to virtualize the hardware that is there in the server, and if you can create multiple isolated virtual environments, so that each of those businesses their computing does not interfere with each other. So, these multiple isolated virtual environment with all that you can cater to these businesses. So, they will behave like independent computers called virtual machines. So, a single physical server with the virtualization technology, it can be divided into multiple isolated virtual environments that behave like independent computers, which we refer as virtual machines, right. Now, virtual machines or VMs, what is this? So, this is essentially to be able to create these virtual machines, actually software layer or hypervisor is created that is used to abstract the physical hardware like CPU, RAM, storage into virtual machine. So, a hypervisor, which is a software layer, which is a software that is used to abstract away the physical hardware that includes CPU, RAM and storage. So, all these virtual machine will feel, and the users of these virtual machine will feel like as if they have the independent computer, but actually it is a shared hardware that is there, and abstraction layer is there, which is removing all the complexity, and every user of virtual machine is feeling as if they have access to an independent computer. So, this software layer or hypervisor does this job, right. Now, next is what is the role of virtualization here. So, virtualization acts like an engine that enables cloud providers to offer scalable on demand resources to multiple users simultaneously. So, because the single physical server, if it can be given to multiple users in using virtual machines by creating virtual machine. So, therefore, virtualization, if you have lots of servers, you can use virtualization to convert all those servers and provide virtual machines, right. So, essentially you can create a scalable infrastructure, right. You can create a scalable assets, scalable on demand resources, and you can cater to multiple users simultaneously because of the virtualization. Whatever physical servers that you are having, use virtualization, create virtual machines and create a scalable on demand resource using virtualization, and then cater to multiple users simultaneously, and that is what cloud computing is about. Now, what are the core components of virtualization, right. So, first core component is host, right. So, this is actual physical hardware server, right, that would actually be abstracted away, that would actually be virtualized. Then we have guest, that is virtual machine that will create. So, this is a software defined computer running its own operating system and applications, right. So, every virtual machine, because it is being given to one user, so it should have that feeling that it has access to, the user has access to an independent computer. So, therefore, it should have own OS and applications, right. So, the guest OS or virtual machine. So, this is software defined computer. So, we have host, which is actually physical hardware, physical hardware server, or physical computer, and then we have the guest, which is sort of virtual computer, which is actually software defined. So, the second component. Then the third component is the hypervisor, we already talked about. So, this is a software layer that sits between the host and guest, right. So, host the actual machine, and the hypervisor sits between this host and the guest. So, for the same server, for the same physical machine, using the hypervisor, we can create lots of guests, that means lots of virtual machines. So, essentially this hypervisor, this layer manages the resource allocation. When a particular end user connected to a particular virtual machine wants a certain resource from which will actually be taken from the same server, right. So, this hypervisor manages that resource allocation and then ensures VMs do not interfere with each other, right. So, let us stop here with the main core components of virtualization, and we will continue in the next session. Thank you.